Hi everybody. Today we're going to finish up our deep dive analysis series of the Hermes Ransomware. In the previous videos we've unpacked the payload, we did a static review of the program overview, we dove into the cryptographic functions. In this last video we're going to go finish up naming a couple of the functions that we weren't able to fully identify, and then find the IOCs. And that's pretty much everything we need to write an in-depth report and to put out the kind of indicators to block them for AV scanners and things of those nature. So in the previous videos, we really focused on static analysis. And generally, when we're doing the deep dive analysis, we try to figure out what's going on statically, and then we'll get the details dynamically. So we have a couple functions left that we weren't able to identify fully. So you can see like this first one, this delete file or copy and start file stuff. We had a general idea statically, but we didn't know all the details. We kind of looked at strings and APIs and a little bit of control flow. So now we're going to dive into the debugger and get those details. Oftentimes the APIs and the control flow will give you what's going on. You can get that general capability. But if you want the exact details, then it's just easier looking in debugger. So that's kind of how we do the deep dive process. We do static when it makes the most sense, and we do debugger when we want some of the details without having to trace variables all throughout the program. So let's kind of step into this function and just take a quick look to review our memory. So I'm going to go a little bit quick through here. So this first part is just picking strings based on, you can see here what the OS is. So it's finding paths, gets a username. Again, this is more for building strings. We see it has this temp directory string, and then we saw the service host a string. That's why we thought we were doing something with copy file stuff. We see a batch, a script extension there. We create a new file. And then we saw these strings for the self-delete. So as we're kind of scrolling through here, you can see the control flow is a little bit complicated. Not super bad, but not easy to follow. We're basically just building strings. And we have this control flow. And then if we get down here long enough, we write out a file. And then a little bit farther, we do the shell execute. And then we see we had this other alternate path here. So this was probably like an if-else statement up here. And down here we have this exe string. We build some more strings with the string cat. We search for some strings. We have this copy, probably out of the command prompt. And then shell execute. We have the start. And so you can see it's really just building strings. We had a couple of strings to search for the strings. And then we're executing. So because of that, I'm going to go ahead and hit Alt left to get back. We're just going to run this in the debugger. And then we're going to see what the strings are built. We're not going to be looking how these strings are built directly. We're just going to wait until they get used. So to start with, before we get into the debugger, I'm going to demonstrate, or I'm going to basically introduce a new script that we haven't used before. And let me go ahead and just pull this up for a second. So we see this is a script. It's in my GitHub page. And so you can download it. It's just in the README because it's not one of my scripts. It's one I found on GitHub. This export to x64 debug. So if I open this up, this is going to transfer all of my marked up annotations into an x64 database so I can import into the debugger so I can get my naming conventions. I only made a couple changes. Added the category up here so it falls in with all of my other scripts, the AGDC services. And then in the main function, I commented out a couple of these lines here. When I'm going to the debugger, I don't really need all of that information. I need to know what the functions are and the kind of data labels. So you can see here I left the function labels and data labels and the defined function bounds. But the prototype comments, statement comments, bookmark comments, all that stuff I don't care about in the debugger. And all it does is add noise. So when I'm looking through the debugger, it makes it a little bit harder to scan through. So because of that, I just commented them out. But everything else is just the same as when I downloaded this. So to run this, all we do is open up our script manager by hitting this little play button up here. And then we go to the AGDC services. And then I select this export to x64 and hit the play button. All this is going to do is prompt me for a file name. So I'm going to go to the C drive, put this in my demo folder. And I'm just going to call this Ghidra labels. And then I'll save it. And this is going to parse through my database and grab all those function and data labels and the function bounds, and they'll export it into just a JSON file. Let me go ahead, close this stuff down. So one thing to note, you see here in my Ghidra, I named the file just with the starting of the SHA-256. But when I go into my x64, you see it has, actually let me just go ahead and open it up here. But you can see it's going to have the, if we go to symbols, it's going to have the hash and then the .exe. So in order to fix the script, I need to go open the script. So I'm going to right click and just edit in Notepad++. And it basically needs to know what module to apply the names to. So you can see here the module name was selected off of my Ghidra database, but it doesn't have the extension. If the name doesn't match exactly, it won't apply the names to it. So all I'm going to do is copy that and do Control F and replace that with the name.exe. I'll do a replace all, and now it'll have the correct module name for x64. I'll go ahead and save that. Go back to x32 debugger. I'm going to F9 to get in my project space. And you see if I scroll down, I have these calls to unknown functions. So I go up to File, Database, and then Import Database. And all I do is select the JSON file that I just created. And now you see we have the nice names that we got from Ghidra. So this just makes it a lot easier to run through the debugger without having to keep on cross-references with Ghidra. So all I'm going to do is scroll down a little bit and put a breakpoint with the F2 on this delete file or copy and start file stuff. I'm also going to put a couple breakpoints past it because I don't want this debugger to actually get away from me, because then it will encrypt all my drives or all my files on this machine, and it'll just make it harder to do the demo. So just to make sure I don't lose track and hit an F9 or an accident, I put a couple extra breakpoints. So I'm going to hit F9 to get into this function, and then F7 to step into it. Then normally when the debugger, I'll literally just run up to functions I care about, either by changing the origin point or EIP, or just by scrolling down and selecting, for instance, this row and just hitting F4 to run to it. But in this case, because the control flow was a little bit more complicated than I really felt like analyzing, I'm just going to step through this pretty quickly with F8. What I'm looking for is any function that does something other than building a string. So building strings, I don't care about until they get used. So I'm really just scanning these APIs as I go along. I know it's going a little bit fast. I'm looking for anything different. So you can see right up here, I see a string, and I can see, let me move this over a little bit. So I'm looking for up here, my module name. I'm looking for the temp directory or temp name. And then the second string, again, I'm checking my full module name, the full file path. I'm looking for public. So this leads me to believe that if I'm running this out of temp or the public folder, then I'm going to take a different path. And since I'm running it out of the demo folder, we can see this jump not equal is not taking. So now let's see. All right, so I'm building some strings. Again, I don't care what these strings are until I use them. I'm getting down to this shell execute, and I can see from my arguments, I'm going to execute the command prompt with this string. I'll look down at this bottom stack view now so I can scroll over. I'm going to copy the running file, the demo hash.exe. I'm going to copy that into the temp directory as service host a.exe. So remember we saw that service host string in there, so now we would know what it's doing. We're basically, looks like we're changing our running file location. So I'll go ahead F8 because copying the file is not going to hurt anything. And then presumably I'll probably execute it after that because that would make the most sense. So I'm building some more strings. And then I get to this shell execute. And again, I'm doing the command prompt. And now I'm going to start. And I'm going to start the temp/svc host A, so the file just copied the ransomware. And passing looks like a command line argument of the original file that I was running as with a trail and backslash. So most likely, if you're copy a file to a new running location and then pass the argument of the old file, generally you do that because you're going to delete the old file, so you're just basically changing the running location. I don't want that to happen, so I can see my command prompt is my ESP+8 argument. I'll go on my hex dump, hit Control G, and do ESP+8. And then I'm just going to select the first couple bytes and right click and do binary edit and fill this with zeros so it doesn't execute. The reason I'm not skipping over it is because I have a bunch of arguments on the stack and I don't want to corrupt the stack, but I want to see what comes after this. My guess is we're going to exit out because we basically just changed our running location, but I want to verify. And we see we get down to this exit process, so I'll go ahead and run that. And then, So all we did was change our running location. So pretty simple. So now I'm going to open up the SVC host out of temp directory. But instead of passing it the original file, because I don't want to delete that if that's what it's doing or modify whatever it's doing, I'm going to create a new document and call this test.txt. I'll open it up and just save off some text, just so it has a size here of a 1 kilobyte. Now let's go into this temp directory, and we see here the service host A, and I'll open this up in the debugger. So I'm going to hit F9 to get in project space. And if I scroll down, you can see we don't have any of our names applied. So I'm going to go back to my Notepad++, and I'm just going to double click and find all the original file names and change this with SVC host A. I'll do replace all, and then save that. And now I can go back into X32 debugger and simply do the file, database, and import database. And I'll select that same file. And now we see we have our file names again. So I'll put the same breakpoints as before, the one where I stop and a couple after so I don't let it get away from me. I'll hit F9. And now I just want to step into this with F7 and do the same thing as before. So I just want to see what it's doing now that I'm running out of the temp directory. So again, I'm just going to F8 pretty quick through here, because I'm only looking for APIs that do something different. I'm not worried about building strings. I'm not worried about how the control flow works. I'm just worried about what happens when I build it, because I've already looked at the function statically and saw there wasn't really anything other than a couple of write files and shell executes. So these building strings, I don't need to know how all the logic works. I just need to know what happens when I get to the end. So now we see a string, and you can see we're searching our module file path for the temp directory again. And then same thing as before, searching for the public. And this time we can see we're going to take this jump because now we found the temp directory because that was in our path. So I'm going to get a command line. So I'm going to put a breakpoint here because I forgot to put the command line argument. So I go back to File, change command line, up. Okay, so it looks like I had to save from previously, so I won't have to restart this, but you can see a C demo test txt with the trailing backslash. And x64 saves a lot of the information once you do it in the database, so we get our command line. And I'll take that breakpoint off now. And then we're going to basically just probably parse. Looks like we're just parsing that command line. So I'll just go past it, hit F4. And then we see this create file. So I'm going to create a file with basically the argument I pass it to, which would, here's the test.txt, but it would normally be the file that we're running at previously. I know my fifth argument is a create disposition, so I go 1, 2, 3, 4, 5, and I see a 2. I can look up MSDN, but I'm familiar with that, and that's a create always. So I know that's going to basically overwrite this demo test.txt with a brand new file. So I'm basically deleting the original running file. In this case, it's just a dummy file, but it would have been our previously running file. So I'll hit F8, close the handle, and if we go back to the demo folder, we see now we have 0 kilobytes, so we can see it did overwrite it with just an empty file. And now we return. So that means if we go back to Ghidra, let me go ahead and close down this script manager. So this delete file or copy and start file stuff, I can hit L to rename this, and I can really call this change running location or delete stuff. And the delete stuff I don't know at this point, but I see there's one argument here. So I basically need to figure out what the other location is, and then see what the argument is. So I'm going to select the function, hit Control-Shift-F to find the cross-references. I see there's only 2. The first cross-reference is where we're just at, so I'll select the second one, close that down. And you can see Ghidra didn't update here, so you can see we're at the same location. But if we look in the satellite view, we have this highlighted one bottom. That's where it got basically selected, and we see the change running location. And that's just, again, kind of bug in Ghidra where the graph view doesn't update that perfectly. So I'll select the EDI. I'm just going to scroll up to see where this gets set, so I can see what another argument is. And I see here, if we are in this path, it zeroes out, and then we can come through here, and nothing else is changing it, which means a 0 would be the argument if we got here. So I could let it run all the way down here, and you'll get the exact stuff. But I don't want to let it encrypt all my files right now. I just want to figure out what the second option is of this change running location, basically delete stuff. So I'm going to go back to x32. And because this function basically stands alone, I'm just going to select the push EDI, right click, and I'm going to do set new origin here. All that did was change my cursor. I'll double click EDI and change it from 1 to a 0. And then just F7 and step into the function. And we're going to do exact same things before. So I'm just going to step through here, and this is overly simple because this is all that's doing is creating strings and then using them. So it makes it pretty quick to step through here with F8. Normally I wouldn't want to do this because you get through too many loops and instructions you don't know. But because here I can scan through these and just look for anything that's not a basically string cat type function, I can go through here quick enough. So all I need to see is what happens at the end. So we have this create file, and we can see we're going to create this file. Let's scroll over a little bit. The temp directory svc host a.exe or a.exe.bat, and we see the fifth argument is a 2, so it's creating a brand new file. Go F8, and now I want to see what I write out. So I see, move this over a little bit. I see these strings for what looks like the standard self-delete string, and that's what we thought it was something to do with self-delete or delete stuff. I just want to go up to the right file. So let me just scroll down, and here's the right file. Go F4, and we see this is pretty short. So we look at the stack. It's the timeout for 10 seconds, and then it's going to delete the svc host a.exe, so delete our ransomware, and it's going to force it, and then delete %0. So if you're not familiar with this, this is a pretty standard self-delete capability. The delete %0 deletes the batch file that's running. And so all this is going to do is we're going to basically execute this batch file, and that's going to delete the running ransomware, and then self-delete the batch file. You can't delete your own file while you're running because of file locks. So this is basically one of the standard ways where you can do a self-delete. We're going to write out that file and just verify that we get some type of shell execute. To do this, we hit a sleep here, probably I think it's just a couple of seconds, so we'll give it a minute. Alright, and now we get shell execute. And we see we're executing the batch file. So again, I don't want to self-delete myself right now. So I see my command prompt is the third argument. So I'll hit Control G, ESP +8. And just like before, I'm just going to knock out, or whoops. Sorry, scroll there. Control G, ESP +8. And I'm just going to right click, binary edit, and just zero this out so it has nothing to execute. Because I want to see what happens after the shell execute. Giving it self-delete, it's almost certainly just going to basically exit out. And we see exit process here. So let that run. And we'll basically reload this. And then F9 get into the program space. So now we can update this name. Hit elder label. So it's change running location or self-delete. And now you see how easy that was in Debugger. It just took us a few minutes to identify the exact functionality. We could have done that statically, but instead of a couple minutes, it probably would have taken us, I don't know, maybe 20 minutes. So you want to get, generally you can get a pretty quick view of what's going on statically. And then, that's the quickest way. But if you need the details like how strings are being built, it's a lot quicker to build those in a debugger than it is to parse them all together statically. So that's kind of how you want to use the debugger versus the disassembler when you're doing a deep dive analysis. If we go back to the top here, I'll select up here with the satellite view. So we had one or two other functions we didn't fully understand. So it looks like the next function we don't understand is this drop persistence file has a question mark. Let's double click here. So if I scroll through here, I see the same string building stuff in the beginning. I see the start menu startup folder, so that makes me think the persistence file. We create a file. And then we see this start, we see %temp, and since we know we're running out of temp directory, that would make sense for persistence. And we also have a start public, so those are two folders, if you remember, that we could have been running out of, the temp or the public. And then we get down to a write file, and that was it. So all we want to really see is what file we're writing. So I'll hit Alt left to get back. And then I'm just going to scroll down to get to my breakpoints. I'm going to hit F9 to get down to here. So at this point, I just want to go into this drop persistence file. So I can put a couple breakpoints after it, just like before. It's very easy to accidentally hit F9 and then encrypt your machine. And then it just encrypts all your disassembled databases and everything to make it just a pain to do the demo. So I'm going to F8 and then F7 to get into the drop persistence. So here, I'm just going to scroll through. And I want to see where I create the file. So I have create file here. I'll just F4 because it's control flow. There's really only one possibility. I'm creating a file and writing out to. And I just want to see the file name. So if I scroll over the stack view, I see it's the startup start.bat. And then I look at the argument, fifth argument, 1, 2, 3, 1, 2, 3, 4, 5. Looks like a 2, so I'm creating a brand new file. So I'm creating a batch script, and then let me see where the right file is. So I'm just scrolling down here instead of single stepping through here. So now I know it's pretty linear flow. I'm going to do F4, and right file, the second argument, in this case is EAX, is my buffer. In fact, we can see this argument here is super short. It's a start, and then %temp / svchost.a.exe. So you can see we're putting a batch file in the startup folder that's going to start our ransomware. So that's pretty simple. All we're doing is starting up dropping a persistence file. So let's go back to Ghidra, and we'll relabel this, hit auto label, and call this drop persistence batch file. And so from this top section, those are all the functions we didn't understand. If I go down to the very bottom, I see I have one more, basically this dropping execute file stuff. This dropping open ransom note stuff is close enough because that was just to the ransomware note. That's not all that important for us. But this dropping execute file stuff, I kind of want to know what note files I'm dropping executing. So let me go ahead, double click this and see what it looks like. Just help me do the debugger easier. So I can see the same setup of checking my OS and building the strings based on the OS. I create a file, decrypt something, I'll write out the file, and then execute. And then I see this right here, this RUNAS, so run as, and then a shell execute. So I'm either going to just drop a file and execute it or execute it as an admin. When you do a shell execute with run as, all you're doing is basically running it as an admin. All right, so that's going to be pretty easy to check. So Alt left to get back. So here I'm just going to change my EIP. It looks like I pass a argument. So I'm going to go to 477 Bravo. Go back to the debugger. And let me see to get back here. Let me just go ahead and restart this. F9. Because I'm going to the, actually, yep, so just F9 to get in the breakpoint space. I'm going to do Control G, and let me double check that address. It's 477 Bravo. So 40477 Bravo. I just added to image base. We see the push. So I'm going to right click and do this set new origin here. It changes my cursor, and I just simply F7 to step into it. Just like before, because this one was a pretty straight code flow, I'm just going to scroll through here instead of F8 down to the create file, so F4, and I see I'm creating a user's public window.bat, and then I want to see what to write out to it. So here's the right file, F4, I'm going to control, actually we can just see it right up in the argument again. I keep on thinking to look in the hex dump, but it's just easy to see it here. So I see VSS admin delete shadows, so it's doing a VSS delete. Let me see, scroll over. So I'm not sure how big that is. So in this case, I'm just going to let it write out. And then you see the last thing to do was basically to one of these shell executes. I don't want to execute this because I don't want to delete my backup copies and just mess up my OS right now. So I'm going to go ahead and hit restart this again, F9 to get into my project space. And I just want to go look at what that batch file was. So I'm going to go to, not the temp directory, this one was the C drive users public, and it was windows.bat. So I'm going to edit this, we see it's going to delete the shadows, resize shadow storage, and then do a bunch more delete stuff. So you can basically see this is just the VSS delete backup stuff. So let's go back to Ghidra. And this one, I can hit the function, hit elder relabel, and call this drop and run VSS delete backups. And if you remember, let's see if we go back to our typical ransomware general process, you can see one of the things generally do was delete the shadow volumes using VSS and potentially other backups. So that's all that's doing. So let's go back to Ghidra. I think that's about all the functions we need to understand. This dropping answer open ransom note, if you're interested, you can go through that on your own, but that's pretty much is just dropping the ransom note. So we could go determine that exactly because we do have the stuff on there. But remember, for the deep dive analysis, you only need to dig into something that adds value to you. So this isn't really a main indicator. I already know, I can see what the ransom note does, pretty simple. I know it's not doing stuff other than ransom note, so there's not any real reason for me to get 100% accuracy on that. If I go back up to the top here, so pretty much I have all the functions now. So I have everything labeled. So now I can kind of scroll through here. I see I change my run location. I generate my key stuff. I decrypt some data sections. I build my ransom note. I get my logical drives. And then I go through and encrypt each logical drive. I come through here, something with IP addresses. And then I build some strings. Again, just build some strings. So I'm just scrolling through here quickly. So I'm building strings. And then I get my list of connected drives. And then I drop a ransom note and encrypt the directories again. So presumably that would be for the connected drives that we just got up here, because the previous encryption was for the logical drives, which is the local drives. This is the remote drives. And then we have the same encryption function right there. Once we get all that done, we basically close everything down, delete our backups, drop one more ransom note, drop a persistence file, and then self-delete. So this is kind of funny that you're dropping a persistence file at the end here, because at this point everything's encrypted and we're even self-deleting ourselves. So there's really no reason to have that persistence file. The persistence file at the beginning makes sense because if this gets interrupted and the computer gets rebooted, it will start the encryption back up where it left off. But at the end here, that looks just like kind of poor programming. So let's go back to our IOCs. So now we basically understand all the functionality. So the last step we want to do is identify the IOCs. So we want to know what region is being ignored, what folders and files are being targeted, the crypto stuff we already have, and then we'll just look very quickly at Yara roles. So let's start with this, what region is being ignored. If you remember from the previous video, I think it was part 2, we go up to the top here. We had this function, exit if target language is found. So we come through here. We see we're checking our installed languages. And we had these values here that if we find 419, we exit out. If we find 422, we exit out. And if we find 423, we exit out. So we need to see what these codes are. So I already Googled this and basically found the available language packs. And if we see our first one here was 419. So I do 0419, and we see that's Russia. Let's see the next one. So this one's Russia, 422 and 23. So Control F, 0422, 22. There it is, as Ukraine, and 423 is Belarusian. So you can see that's pretty common for ransomware is to ignore Russia and some of those kind of like Ukraine type states over there. So, that's one other IOC that we have. So you can see how, that's pretty quick. We could have done it while we were first analyzing it, but I tend to like to do things kind of in order. So as we're trying to identify capability, you keep your mind set into that, you don't go off in tangents, and that way you kind of get a little more efficient. Now we want to know what files and folders are being targeted. So that's just an encryption function. So I'm going to hit Alt left to get back. And let's scroll down here to get to our first encryption function. So we see here, we get, let's expand this out, get our drive type. If we're not CD-ROM, we're going to encrypt the directory. And basically, because we know we've got a get logical drives here, we're most likely just passing the drive into here. And if we step into it and double click it, we can see we're appending a star.star. So we're going to encrypt everything in that drive. So when we're running through this, I could let it run that, and I could go down to the find first file, see what file it's looking for, and then work from there. But that gets a little bit not complicated, but it's easy to mess up, and it's just a little bit of a pain. So what I do to make this easier is in my demo folder, I created this folder. It's called A, and I put basically test1 and it's our test.txt and so txt and exe, and I just put some sample data in there, so you can see if we open one up. And this file happens not encrypted if it's too small, so I just added 40, 50 bytes in there. Same thing for the exe. And what I'm gonna do is basically I'm gonna patch out this string cat, or actually I'm just gonna modify it so that instead of like the C drive star.star, I'm gonna do the C drive demo a star.star. The only thing I need to note is that I'm using a find first file W. The W means you're doing wide characters, so I need to do this in Unicode. So first I need to put a breakpoint on this push here. So 1 delta 2 9. So go back to debugger, Control G, 401 delta 2 9. Put my breakpoint, and I will F9. And then F9 a couple of times to get up there. So now I'm going to hit Control G, go to EBX. And I see it's just a C drive. So I'm just going to select the first couple rows, right click, binary edit. And then in this Unicode part, I'm going to add in my full path. So C drive, /demo, /A, and hit OK. And now we have the C demo A. And we see when we do this string cat, we're only going to be looking for files in that demo A folder. So this means if it gets away from me, I won't encrypt my whole machine. I know what files this be looking for, and it just makes it a lot easier. So now that we have that done, let's look at it statically. Because we don't need to do this in debugger. Some parts are going to be easier. So I'm just going to scroll through here and see where I can find what files or folders are going to be targeted. So I can see I'm searching for a dot. And then I'm searching for dot. That's pretty standard when I'm searching files. If I don't find those, you see if I find them, I find the next file. So now I have a file. So here I can see it looks like I'm building strings. I have the moves D. It looks like I have a Windows, ANLab, Microsoft, Chrome, Mozilla, and Recycle Bin, Windows. And then I do a string here and a bunch of strings. So I need to know if these are targeting or ignoring. I also want to see what these strings look like in the debugger, because at this location, it looks like you can read them off, but because of how this is doing the copy, I could be making a mistake. Maybe this is only part of what I'm seeing, because we're adding the first 4 bytes here, then we're adding the next 4 bytes here, next 4 here. And so it just becomes a little bit of an easy way to make a mistake, so I want to see that in the debugger. So if I find this string, I'm going to return the pointer to the location found, so it'll be non-zero. So that means this jump here would mean I found the string. Same thing here. This test jump not 0 would be here. Let's just kind of scroll through here, and you can see all these are jumping out to the same location here. So if I find one of those folders, I'm going to take this blue path and go back to find next file. Let me get back to where I was at. So that means all these locations are my avoid list. So all I'm going to do is basically run up to here and then see what these strings are. So 1 echo 84, Control G, 401 echo 84, and then F4 to get up there. So I can see here I'm checking my module name, test.exe, and I'm looking for Windows. So I know I'm going to avoid the Windows folder. And now I'm just going to step through each of these strings. I'm going to avoid ANLab. I'm going to avoid Microsoft folder. I'm going to avoid Chrome folder. Avoid Mozilla. Avoid Recycle Bin. Avoid Windows. And that looks like it. So just as a kind of a reminder, so the reason you avoid those folders, like for instance the Windows folder, is you don't want to encrypt system files because then it bricks the machine and there's no way to read the ransom note and you can't pay the ransom. So all they're trying to do is encrypt user data, and they probably skip the things like the Firefox and the Mozilla folder because they open up some of these ransom notes inside a internet like the Mozilla, and so that way you can actually use the browser in order to read the ransom note. So I'm just going to F8 through here a little bit. And let me go back to Ghidra, because now we have our IOC for, we know what folders are being ignored, but we still want to know what files are being targeted. Let's go back to the graph view. So if I get past all this, I will, let's see, string. So if this is null, I'll come down into here. And then it looks like I will go out this red path. So that means none of the strings were found. And then I take this red path. Now I check if I'm a directory. If I'm not a directory, I will go down this green path. And now I'm checking for the decrypted information, so my ransom note. I check for my unique ID do not remove. So here I don't even need to check the path because we now, from the previous video where we dove into the crypto, we know the unique ID do not remove is the crypto keys generated specifically for this host. So we know we can't encrypt those because otherwise there's no way to recover the information. So that means we're going to be ignoring that file. And then we come over here. I see some type of string length, a to upper, and then I'm checking a string here, string. If we find the string, not 0, I'm going to jump over here and then find next file. So that means these are going to be ignore. Same thing here, jump not 0, and I will find next file, so that's another ignore. If I don't find those, I come over here and I encrypt the file. And otherwise, it looks like I come down here and increment some pointers. You can see here, add ESI 32, add EX 32. Let's scroll back up and see if we can see what these strings are we're checking for. So the first string, we're checking ESI, which is global variable. Let's go into the flat view, and I'll double click it. And we see it's 65XC, so in Unicode, I right click, do data, and terminate a Unicode, and we see it's EXE. If I go back to here, so you can see that's in ESI, and if I scroll down here, and when we went back to this loop, we see we add 32 bytes to ESI, and then we go back up. I just scroll this over a little bit. We come back all the way back up to here, and we do a string length, and do this to upper, and check this stuff again. So let's go ahead and add 32 hex bytes to that. So we're going to here, and I'll just kind of scroll down here because 32 is not hard to see. And I see a DLL, so right click, data, Unicode. Here is the LNK, so I go right click, data, Unicode. INI, right click, data, Unicode. HRM log, right click, data, Unicode. And that looks like it's it. So we can see we're avoiding HRM log, .ini, .short LNK, .dlls, and .exes. So alt left to get back. So this first string, we know we're avoiding, but we need to know what the second one is. We see this 734 we use for between both of them, so that must be our file name. So let's see what this local fcharlie is. So I scroll up. I'm just trying to see where this gets set from. So I see here a memset. And unfortunately, this is something you just have to get used to with Ghidra, as Ghidra makes some mistakes with labeling these stack variables. So the fact that this is zeroed out at this up here, and then right down here it's used, that means this has to be built somewhere between here. So if I select this actually 2's complement offset, the all F08, and I scroll over, you see here I have the all F08 inside of a buffer that we're putting a byte into. So that means this is basically EBP plus FFFFF08, which is the same as up here. So local fcharlie is this FFFFF08. So I can right click and do references, add edit, click the plus button, hit stack, and then do this as minus 0x Charlie. And hit OK. And now we can see if we select it, we see we zeroed it out up here. We do this to upper, and we can see it's from the exe up here. We check our exe, and we check our uppercase exe. And then we basically go increment our stuff up here and loop back around. So now we can see we know basically the avoid extensions. But just to make it so we can get a little practice, let's go ahead and verify that in the debugger, because maybe you wouldn't be able to track down that variable and you wouldn't know what this to upper is. Let's just kind of scroll through here and see what these strings are so you can see them in the debugger. So all I'm going to do is F8. In fact, let me just go to that code. So it's a 21 Bravo 6. Control G, 4021 Bravo 6. And I will F4. And we see test exe. We're searching for exe. So in this case, remember we thought it was a void. And we can see not 0. And now we see find next file. And then we loop back around. Let me go back to that location. So this was 21 Bravo 6. Control G, 4021 Bravo 6. And I will F4. And now it's test.txt. And it's searching for exe. Not found. Searching for capital exe. Not found. And now here they're going to jump below. So basically, we'll just loop through this one more time. And we can see we're going to this to upper again, building it out. And then we'll do the string. Now we're checking the DLL, capital DLL. And instead of running through this because we already saw those 4 or 5s, I'm basically just going to skip past this jump below and hit the jump. In fact, I know I'm going to get to this virtual alloc, string copy, string cat, and then script file. So let me just F4 up to the script file. This is a test.txt. We can see is the argument. So I'll just F8 it. And then find next file. We should be done. Find close because we only had 2 files in there. And we returned out of our function. If we go back to our demo folder and go into this A, we see this test.txt is now encrypted. If you remember when we were going through this program overview in the part 2 video, remember there was a Hermes string it was searching for? We can see here it's got this Hermes string. So if we really want to, we know what follows that Hermes strings plus something, and then it had basically the crypto keys included in there. If we want to see what that little something was, we could go in the debugger and verify that, but it's not really all that important. It's not really an indicator we need to find. If we're doing an in-depth report, I might want to go through and verify it to put in the report, but just for finding IOCs, it's not really something that matters, so I'm not going to spend the time doing it. So let's go back to our document and see if there's anything else we need to do. So we basically know the general process. We went through statically in determining all the general capabilities. We found all the functions where it decrypted data. We found the regions where it avoided. We saw how it encrypted the files. And then we saw it delete the ransom notes or the shadow volumes. And it didn't have any networking. So we have all that capability labeled. We know what region is being ignored. We just searched for that today. The files and folders. So we know what basically does a ignore list. And we know what those values are. The crypto information we got from the last video. The last thing we want to do is look at Yara rules. Yara rules I'm going to do very quickly and just not really go into them. I just want to talk about it for a minute. Because when we're looking for Yara rules, there's a couple of things you want to look for. You want to look for something hard for the actor to change, but that doesn't take you forever to find. So it depends if you're looking for a quick indicator to kind of stem the bleeding, or if you want to find variants and kind of do a more thorough blockage. So in general, I might start with the quick indicators and then put those out and deploy them, and then spend a little more time to find better Yara rules that help me find variants and find changes, and then block those also. So in this case, one of the easy things we can look for is in this encryption function. So we saw this avoid list for the extensions. So if we go back to the flat view and we double click it, so just a string exe, DLL, LNK, INI, not all that unique, but these strings in this order, separated basically by 32 hex bytes, is pretty unique. So we could just make a string on this large extension void list, and that could be a quick indicator of block all the versions of this Hermes ransomware, unless they made some changes to it. So obviously that's really easy for the actor to change, but you could block it for a while you do some better signatures until they go through and make the changes. Now, even though it's strings and extensions, they're probably not going to change the extensions, but they could add garbage data in there, so it's not separated by a bunch of null values. They could change the order, things along those nature. What we would rather look for is some bytes. In ransomware, I'm going to hit Alt left to get back to the main part. So one of the things you can often look for is where you're getting logical drives. It's not the best one in this file, but you can see after we get the logical drives, we had this push pop for the 26, and then this code that is basically going to do a bit mask where it's shifting the bit mask of the get logical drives, testing until you get one is basically turned on or true, and then we'll go through basically create your path name and then call the encryption function. So potentially, because you do the push pop for the 26, and then because this is actually going from 26 down to 1, it's actually a little bit more unique. Normally you count up instead of counting down. So potentially from this 4435 up through this 4440 could be a unique Yara rule. I might even include the call to get logical drives. I would just wildcard out the actual address for the get logical drives function call, because that jump is going to be different in every compiled binary or every machine, so it's just dynamically loaded. So in this case, I either do it from the call with it wildcarded out, or just start from this push and then see how it works. This would only be to test, because it's a pretty standard way ransomware gets their files, but because I do the push pop and then going backwards, it's a little bit unique. There's a good chance you'll find the Hermes ransomware. You might not even find other ones. If this was a separate function, I would say this would be a pretty decent bet, because even if they recompile different parts of the ransomware, change the strings, the function probably wouldn't get touched, because you're not going to change how you find the logical drives that often, and so the assembly probably wouldn't change. The downside here is because they have it in the main entry where everything else is done. Even if they make other changes that's not has to do with this, like get logical drives, but it's just in this main function, it very well could change the registers that are used from here from the compiler. So that makes it not the best one, but it's a possible one to look for. So that's really all I want to talk about for the Yara rules. Again, we're not going to do in-depth. Maybe I'll do a video about that a later time. This is just to get you started what you think about. So I hope you enjoyed the video today. That's really everything we need to talk about. So because this is the last video of the deep dive series, I'm going to post the annotated Ghidra file inside my GitHub page, and so you can download it and review it in your own time. You can also get the ransomware from Malware. That's the hash is in the video description. So definitely recommend downloading this and looking at it your own. See, kind of give it a little time and then try to analyze it and see how you do, kind of what you come up with after it's not so fresh in your memory. And then that's really all we need to do. So again, I hope you enjoyed the video. If you did, please like the video below and subscribe to my channel to get notified when new videos come out. If you want, I also love to know what you think, so leave me comments below. If you want more reverse engineering tips, follow me on Twitter. And if you're interested in structured training, check out my website for the malware analysis classes I offer. Until next time, keep on practicing and try to learn something new every day.